Can you all hear me? Can you guys give me this sign? Okay, great. Okay, so let's get started. So welcome to all of you who are joining this event from South Korea and also from UAE. I know it's a bit late for some of us, but I really think and hope that the next 2 hours would be a really exciting and memorable time to all of us here. So let me welcome you and thank you again on behalf of Young Astronaut Korea for joining the Korea-UAE Youth Aerospace online program. My name is So-Young Chung and I am a senior researcher at KOR-UAE. It's my great pleasure to serve as an MC for tonight's event. Unfortunately, due to the COVID situation, we could not have a face-to-face event. But I think it's really exciting that we can have this exchange program still online with more than 100 students joining from both countries. And as we all know, South Korea and UAE share the dream of becoming more advanced space countries in the future. And it's really up to you, the next generation, to realize these goals. And UAE and South Korea has what we call a special strategic partnership. And as we will hear later today, we also have a very special relationship in the space field as well. And I'm sure that having students from both countries together to learn about each other's space activities and to have you get to know each other as friends will help us strengthen our partnership in the space sector and also at the national level. So this is really fantastic. And with that, let me get started with today's program. So today we will have, today's event will be divided into 2 parts. In the first part, we will have a special lecture from each country. The first lecture from South Korea will be delivered by Dr. Eugene Kim from Satrec Initiative. Dr. Eugene Kim is the Vice President of Business Development for Satrec Initiative. And he has the responsibility for leading the strategic planning and technical marketing for international businesses for Satrec Initiative. And Satrec Initiative and Satrec Initiative originally started from Satrec, and it's a spin-off company that originated from there. They have a very, very, very interesting story, which will be very inspiring for both Korean students and also for UAE students. So I hope you enjoy his lecture. And the second lecture will be given by Omar. Sorry if I spelled this wrong, but Omar Abdel Rahman Hussain from Muhammad bin Rashid Space Center. As we all know, UAE has a very exciting UAE's Mars mission, and he will be speaking about the Mars mission. So without further ado, let's get started with our speakers. Dr. Eugene, the floor is yours.
Okay, thank you, Ms. So-Young Chung, for the kind introduction. Let me try to share my screen first.
Right. Eugene, before you start, let me give some instructions to the students. So students, if you have any questions, you could either leave your question in the chat, or you could ask him the question directly after his lecture is over. We'll have a 10-minute Q&A session after his talk. So go ahead, Eugene.
Okay, thank you. So today, my talk will be about, I'll briefly talk about the buzzword these days, new space. And then we'll talk about us, how we started, what kind of satellites we build, and which direction we are going to. And then we'll also, of course, we'll talk about how we got to work with our Dubai partner. Right. Next slide is, raise your hand if you don't know this guy. I'm sure everybody knows this person, famous for founding SpaceX and Tesla, well, leading SpaceX and Tesla. I think the most popular buzzword these days is new space. And I believe he is the most to be blamed to make this word popular by revolutionizing the way we can launch satellites up in space, by reducing the cost of launching, by reusing the rocket engines. So that's how he is revolutionizing well, that's the biggest part. And on the satellite side, satellites are becoming smaller and smaller, and they are, because the launching cost is cheaper and the electronics got better, they can launch a lot more smaller satellites to do the same job at a fraction of the cost. And for the case of Earth observation, with more satellites means you can take the pictures more often. So this is an example of a company now called Planet, once owned by Google. And I think I took this from Elon Musk's Twitter. And this is what's happening these days. SpaceX is launching 60 Starlink satellites at a time per one rocket. In the older days, space used to be hard, space used to be expensive, space used to be led by governments to launch big and heavy and expensive satellites, but this is what's happening these days, led by commercial companies. They can launch like tens of satellites at a time, and they are trying to launch thousands of satellites in orbit. So that's what's happening in the space industry these days. New space. But to us, when I see the news, I feel kind of I think it's kind of ironic because of this picture. So fast forward rewind the clock about 30 years. This shows students who are waiting who are happy to see the completed satellite, which is about 50 kilograms. Second from the left is Mr. Sung-Dong Park, the founder of Satrec initiative, when he was about 25 years old, with a lot more hair than these days. And that's how we started in Korea. I mean, this was like a small sat. We called it small sat. And these days, they called it new space, but to us, it feels like it's nothing new. There's nothing new under the sun space to us, because we've been building our satellites like this since 30 years ago, meaning it's cheaper products, cheaper components, and smaller satellites, more experimental satellite than large, big satellites. So that's how we started. 4 students were sent to the UK to learn how to build a satellite. We started from a small research center within a tech university called KAIST. And the program ended up by sending a total of 27 students. Sung-Dong Park was, I usually say, serial number 1 of the batch, 27 students. And I was serial number 27. I mean, he was serial number 1 and I was number 27. So I was the last in the group. We came back and launched the very first Korean satellite called KitSat-1, like I showed you in the last slide. And after building 3 satellites in the research center, we spun off as a commercial company. And we've been in business for over 20 years. So that's where the name comes from, Satrec used to be, well, it still exists in KAIST, Satellite Technology Research Center. Okay, so about 30 years ago, this was a kind of pictures, satellite pictures we could take from this. These are taken by KitSat-1. And if you look at carefully, you can probably see, maybe able to see UAE somewhere around here, covered by clouds, and Korean Peninsula here. So this was the kind of satellite pictures we could take. And fast forward about 30 years, Satrec initiative today, we've been involved over 30 projects, both in international and domestic programs. And we now have over 400 full-time staff, including 2 subsidiaries. And when we started the business, we were wishing the government, Korean government, spent on us like tuition fees and living costs to send us to the UK and abroad. That was about $10 million at the time. So we were hoping maybe we can earn twice of that, $20 million, to repay the debt. And we've been in business for about 20 years, and over 20 years, we won the contracts over $600 million. So we went a little farther than we hoped from the beginning. We are now listed on the Korean stock market. So we became these days one of the world leading Earth observation small to medium satellite systems providers in the world. And these days, some examples of pictures we can take. It's been already several years, taken by Deimos 2, which we delivered to Spain, 1 meter resolution. This is a World Cup stadium. We're expecting World Cup next year. And this is the Apple Park. This is actually a moving GIF taken over time, how it was being built in Cupertino. And so I am deliberately showing actually time series of this picture because I'll tell you why later. And this is a picture of Pyongyang, the capital of North Korea, our troublemaking cousins in North. And this, you can see that I think they were about to prepare for a parade in a square. So you can see the quality of satellite pictures that we can take from the satellites we build these days. And these have been already a few years, so we are building something better than these today. So overall, we are in the, I did say we have 2 subsidiaries. And in short, these are the areas we are working these days. Left 2 are done in Satrec initiative, the mothership. The first one is we design and build the entire satellite, small to medium satellite, including the payload and the spacecraft bus platform. We call it bus. And the ground systems, the entire software for the ground systems. So, and our first subsidiary daughter company is SI Imaging Services. And it specializes in, they are the sole operator of COMSATs, which are developed and built by KOR-UAE, the National Aerospace Research Institute. And we live 15 minutes away from them. We are located 15 minutes away from them. And the newest daughter company is called SI Analytics, which specializes in artificial intelligence algorithms to automatically detect objects in satellite imagery. So these are the fields we are working on these days. And this shows the pictures of the satellites programs that we've been involved. Starting from KitSat 1 about 30 years ago. And most of the Korean government programs we've been involved in as ground stations supplier. And the ones in the circle are the ones we provided outside of Korea. I'll come back to this point. And we have partners in all around the world, except pretty much North America and Africa yet, starting from Southeastern countries and also our Middle Eastern countries, UAE being the most important partners so far, or one of the two most important partners. And these show this slide shows the satellite programs that we supplied outside of Korea. So starting from Malaysia, enter UAE, I'll come back to UAE again, Spain, Singapore, and some countries that I am not allowed to name. So these are the entire small to medium satellite systems that we have provided outside of Korea. And the last two we are building right now to be launched early mid next year. And in the bottom row, we have supplied we specialize in optical cameras for satellites in different countries. 5 of them are in orbit, and we are building the last one at the moment. So we believe the edge comes from our capabilities to design and manufacture the core components in-house. I think of it as a SpaceX. SpaceX pretty much designs and manufactures all the components within their company. Of course, we buy some components from outside of Korea if it doesn't make sense to manufacture, make sense economically. And it also applies to satellites. So we build our own, we write our own software, and we build our own hardware. So we control both hardware and software. You can think of it as an Apple, just like Apple. And this shows the evolution of our satellites. So we started from SpaceEye 2, which had the resolution of 2.5 meter and 1 meter, half meter, and 0.3 meter. You can see the satellites are getting larger as the resolution of the satellite image is getting better and better, because it has to carry larger and larger cameras. You can see the aperture of the camera is becoming larger. We call it camera, but it's actually just like a Hubble telescope. It's like a astronomical telescope looking down on Earth. So one direction is the quest for better and better spatial resolution. And the other direction we are going to is for better temporal resolution, let's say, meaning we are building smaller satellites, like less than 100 kilogram satellites. And I'll come back to this point again, but with more and more satellites on orbit, you can take the pictures of the same site on Earth more frequently. So these are the two directions we are going to these days. And I like to use these pictures to my sons. I have two boys, one in middle school and one in elementary school. You can see on the left, this is a famous Korean football player playing in English Premier League. And if you want to take a good picture of him, close-up picture of him, you need this kind of bazooka type telephoto zoom lens, the largest commercial camera you can buy, because you cannot get close to the players while they are playing, right? And not sorry about the quality of the pictures, but hope my favorite, the favorite boy band to my boys is they are BTS, and you can see the pictures taken by smartphones. And if you want to take good pictures of the singer, you have to get really close. And just like the case of a football player, if you are using this kind of camera, you can never get a good quality close-up picture of a player, your favorite player. And just like this analogy, this kind of exemplifies two directions we are taking. One is for the better and better resolution using bigger and bigger cameras. And the other direction is using smaller satellites, but because the satellite is smaller and cheaper to build, you can build a lot more of them, right? So that's an example I like to use. So in the near future, what's happening in the field of satellite Earth observation is like this. In the past or now, expensive and large few satellites are taking very good pictures, and human analysts are used personally look at the image to analyze the satellite imagery. But these days already what's happening is, because a lot more smaller satellites can be launched, thanks to Elon Musk and thanks to companies like Satrec Initiative, we can build a lot more smaller satellites, which means a lot more camera means a lot more picture data, right? So it's basically big data of satellite imagery. And because it's too much data for human analysts to analyze, you need artificial intelligence help from computers to analyze the image data, right? So that's the direction we're going. And recently we announced the program called Space IT, which can take the pictures of the 30-centimeter resolution, which was the largest satellite that we built, to be launched in 2024. And this will be operated by our own daughter company, and the other daughter company will provide the AI tools for this. And these days, there are only two companies on Earth who can provide this kind of imagery commercially. One is Maxar from the USA and Airbus from France. So state-of-the-art market is dominated by these two companies, and will be the third commercial company who can provide this. We call it very, very high resolution satellites, EVHR. So that's, yeah, to be launched in 2024. So that's one direction. And the other direction is the other spacecraft we are building right now is Space IM, which has about a bit better than 1 meter resolution, better than, smaller than 90 kilogram. And we are right now building the Pathfinder. The Pathfinder will be launched in 24, And we call it constellation, as in a star constellation. So it's not just one satellite, but group of satellites. It will be in total of 11 satellites. The constellation will be complete by the 2027. So that's the other direction we are headed. And one day, we have a dream to overtake. We started humble, but one day we have a dream to overtake American or European companies in certain fields. Not all fields, but that's our dream. So now enter back to UAE story. Deja vu, we see 4 young students. Well, they were not actually fresh out of the university, so technically they were not students. And they came to Korea about 15 years ago to learn how to build satellite. They came to us and they developed 3 satellites with us. And most recently, they launched KHALIFASat 2018. So this was their strategy to build their expertise. So they started with DubaiSat 1. Total of 8 engineers came to Korea to work with us. And they were involved about 30% of the work. And before the first satellite was launched, DubaiSat 1 was launched, they started DubaiSat 2 program. And they sent a total of 24 engineers to Korea to develop and launch DubaiSat 2. And then before DubaiSat 2 was launched, they started the 3rd satellite program, DubaiSat 3, later changed the name to KHALIFASat. And the engineers went back to Dubai and now took the initiative, and they were in the driver's seat, excuse me. And we became only component provider to them as a strategic partner to Dubai. So that's how they, Dubai, accumulated their expertise to build satellites. And some pictures of how we did it together. So this shows DubaiSat 1, case of DubaiSat 1, we worked together. And I think this was DubaiSat 2. Yep, worked together again. And not only work together, we worked hard and played hard together too. So we did some soccer. Actually, they were Dubai engineers were really good, excellent soccer players, and they became part of Satrec football club. Played with us, and they also took some master's course at KAIST, and they received the master's degree. And they went to a workshop in Jeju Island. So that's how we worked and played and studied together. And this shows the KHALIFASat program and the top leadership visiting the MBRSC in Dubai. And what we learned throughout the partnership was the interest and strong interest and support from the top level leadership was critical to the success of the Dubai's space programs. And not only just the interest, but also financial support over more than 10 years, 15 years. And they kept the programs overlapped, and which meant they did not have to lose the engineers. And engineers did not have to find jobs elsewhere, but they could focus and keep continuing their work on space programs. So that was the very good strategy of Dubai. And I think this was a launch site for KhalifaSat. And now we all know, in a sense, they went, well, far beyond where we went to. So this shows the program of, well, Mars mission, Emirati Mars mission called Amal. So this shows how we work together, and then how the Dubai partner, Dubai friends, went farther than us. So we call it, in a sense, the student has become the master. Okay, so they are right now working on their own next program called MBZSat, to be launched in 2023. Okay, so even Nature was very interested in how they did this in such a short time. Yeah. So I think that pretty much wraps up my talk. And to summarize my story, I mean, Satrec initiative started. We started as from our humble research center, and now we became one of the most important satellite manufacturers in the world. And we could not have done this without the partnership with our partners in Dubai. And I think it was a mutually beneficial partnership between the two entities. And we have a strong belief that now our partners went even further than us. And not only us, but Dubai friends in Dubai have busy years coming. So good luck to them. And so that pretty much concludes my talk today. And I'll be happy to take some questions.
Well, thank you, Dr. Kim, for very inspiring talk. I think Satrec initiative story, and particularly your story of partnership with UAE, it's a very, very beautiful story and a very good example of how international cooperation should be done in space. And for students, I left a message in the chat. You can either leave your question in the chat, either in English or in Korean, but you can also raise your hand. If you know how to raise your hand using Zoom, please raise your hand. I will try to spot you.
I believe the students are smarter than us.
Well, you guys are working on your question. I just wanted to make this one comment. So I actually know one of the students, the first students who were sent to Satrec initiative, and he became the project manager for the Mars mission Hope. And I personally became really jealous of him. But this is really a very beautiful friendship to have. And while I was making that comment, I think we did get our first question in the chat in Korean. Should I translate the question into Korean? So this is, so she liked the analogy you made about the pictures. And she said she thought that it was brilliant. And she wants to know what was the key point, the main factor that allowed UAE to grow so fast in the space sector. So she's asking that question to you, Dr. Kim.
Okay, thank you for the translating the question. I believe the comment was about the analogies about the football player, big cameras needed to take pictures of football player, and smaller cameras, many smaller cameras used to take pictures of close by objects. And thank you for the comments. And I think I think I briefly mentioned in my talk the reason why UAE was very successful and very efficient in their space development was I believe I like to point out three things. First was, like I said, strong interest from the top leadership. And second point is sustainable support for their space programs. So we have seen in the past some other countries who started one program with by one satellite, but did not keep up the next program for the engineers. So engineers had to find jobs even outside of engineering to make living. So I think that's another point that UAE did very well. And the last point, I think for starting countries like, well, not UAE anymore, but any other country who are starting fresh to work on space, to start a space development program is to find good partner. I like to say marriage is important in your life. So you need to find the good partner if you are starting from zero. Okay, so hopefully that answers the question. And okay, the next one. Of course, please, you can turn on your mic and ask me, 승욱 Choi, 최승욱 씨. 네.
Okay, hello.
Okay. While we wait for 승욱 Choi to turn on the mic, I'll move on to the next question. The next question is, why are the Korean satellites are shaped as square or rectangular or hexagonal? Any reason for this? I think the quick answer is that's how we learned from the UK guys. We started as it was like I showed you in early slides. It was a box shaped. It's actually stacked module. So each module is like a very thin rectangular shape and easy to stack the modules. So I think it would be easier to make them square modules than like circular modules. So I don't think other than that, I don't really see any specific reason to pick square rectangular shape. And for the hexagonal shape, I think it's because it's built, the spacecraft was built around a round shaped cylindrical payload, which has the cylindrical baffle, while the tube shape. And rather than using rectangular shape, because the platform was built around the payload, it was better to build like hexagonal shape. Hopefully that answers the question. And I'll move on to the next question by Won-dong Min. So I did show the time series of Apple Park in Silicon Valley. And this was, so using one satellite, it typically takes about, depending on the allowable tilt angle, but in this case, I think it was looking straight down on Earth rather than tilting the satellite to take pictures of the same target. So in this case, I think it must have taken more than 15 days to come back to the exact point on Earth. So I think the pictures I showed you, it was taken over like months to show the progress of the construction of the Apple Park. And so it does come back to the exact same point if it takes more than 15 days, tens of days. So it can come back to the same exact spot. But if I wanted to point out in the two directions, one of the two directions for higher temporal resolution, meaning if I can have launch like 10 satellites, I can take the pictures of the same site a lot more often than the example I showed you using only one satellite. Okay.
Dr. Kim, sorry for the interruption, but can you stop sharing your screen so we could see your face? And I think we'll have time to take one more question.
Okay. Okay, so one last question. Back to Seunguk Choi. Question about the optical payload. On-axis type. This is sounds very optic-y. some optical background here. The question was whether the optical payload was on-axis type. Quick question is no, not. This was off-axis type. These were mostly off-axis type, except the very early day optical payloads, which were Ritchie-Chrétien, modified Ritchie-Chrétien type telescope. The last question was, how can we achieve such a performance using from such a small satellite? And like I said, the advancement in the electronics, especially the detector side, and also we are using in fact the largest telescope we can put on a small satellite. So it's in fact not a small telescope, but for example, for 30 centimeter resolution, the entire satellite is taller than 3 meters. So I call it like Libyan oil pipe. It's huge actually when you look at it in the lab. So hopefully that answers the question. And yeah, I am being stopped because Omar, our next speaker, is waiting.
Right. So I guess with that, we'll have to stop here. But Dr. Kim, you could still answer the questions from the students using the chat during the break.
Okay, we'll do.
Right. So thank you very much. Thank you for the fantastic lecture again. And everyone will take 5-minute break. So please come back at 11, and we'll start with the second lecture by Mr. Omar. Thank you. Thank you.
Thank you, Soyoung Chung, for this great opportunity, and thank you, Yak, for giving me this opportunity.